Hey guys, in this video we're going to be covering 1D.3, which is being able to solve real-world problems by solving exponential equations. First example here says the number of members in a club is doubling each year. This scenario can be represented by the equation n equals 3 times 2t. That's important, where n represents the number of members after t years. Alright, so n is the number of members, and t is how much time is passing in years. Third question says, how many members will the club have after 1 year? So this right here is indicating time, which is represented right above by the letter t. So this is whenever t is equal to 1 year. So I'm going to write my equation, n equals 3 times 2t, and I'm going to substitute in my t equals 1 anywhere I see that first power. So n is going to equal 3 times 2 raised to the first power. 3 times 2 to the first power is just 3 times 2, which is 6. So therefore, I'm going to have 6 members after 1 year. Next question, after how many years will the club have 24 members? So if this is members, this is number of members, which is represented by the letter n. So this is whenever n equals 24. So now I'm still using that same equation, except for I'm going to substitute 24 where I have that n. So n is going to equal 3 times 2t. I'm going to substitute in 24 for n times 2t, and I need to solve for n. So it's an exponent, so I have to isolate it, and I am multiplying by 3. So the opposite would be to divide by 3 on both sides. 24 divided by 3 is 8, equaling 2t. I look back at my powers cheat sheet. So looking at our powers cheat sheet, I'm trying to find like bases of 8 and 2. So looking at all the numbers that multiply, looking at my powers of 2, I do see that 8 can be rewritten as 2 cubed. So going back to my word document over here, 8 can be rewritten as 2 cubed. So I'm going to replace 8 with 2 cubed. Leave the right side the same as 2t. And now I look back at those steps back in video 1D.2. When my bases are the same, I have base of 2, base of 2, all I have to do then is set my exponents equal to each other. Therefore, t equals 3. I found my answer. Number of members is going to take 3 years. Right? T was time. 3 years to have 24 members. Alright, moving on to our next example here, example 2, where it says a population of beetles can be expressed by the equation t equals 800 times 5t, where p represents the population after t months. So p is population, t is months, and we have our equation right here. Alright, so how many months? We have 8 months. This is representing time. So t equals 8, and I'm just going to substitute in t wherever I see that t, I'm going to put in 8. So t equals 800 times 5 raised to the 8th power. Now, we have our calculators. So that's all we have to substitute in to our calculator here. We have 800 times 5. Remember, we have to raise that 5 to the exponent, right? 5 raised to the 8th power. When I click enter, I do get this nice big number, which is 312,500,000. That's 312,500,000 beetles after 8 months. Don't forget those units. Let it be. How many months will it take for the population of beetles to reach? So here's our population, which is P. And we have to substitute that number into our equation. So P equals our 800 times 5T. We're looking for how much time has passed. My population here is going to be 12,500,000 beetles. My 800 doesn't change. My 5 does not change. But I still have that power of T, which is what I'm trying to find. I have to isolate that exponent. So if these are getting multiplied together, I'm going to divide by 800 on both sides. I'm going to use my calculator here on the side. So if I have over here 12,500,000 divided by 800, I get 15,625 equal to 5T. Alright, now I need to find my basis. So 15,625, and I have a 5T here. Looking at my powers cheat sheet, I know I'm going to be changing in bases of 5. So if I have, the biggest number I have here is 5 to the 4th. So what's a good thing is, well, let's check what is 5 to the 5th power. Looking at my calculator, 5 to the 5th power, 5 raised to the 5th power is only 3,125. It needs to be a bigger number. So let's say 5 to the 6th power. 15,625. Nice. So that's exactly what I needed. So I'm going to go back here because now I know that 15,625 can be written as 5 to the 6th power. Bring down my right side. I have bases here, so I set my exponents equal to each other. My T equals 6, so I have to wait 6 months for my beetle population to reach that 12,500,000. Alright, moving on to the next page. I have example 3. Your crazy rich uncle dies and is leaving a large amount of his fortune to you. However, you will have to wait 10 years before you can receive the money, and he wants to test your math skills. He gives you 2 options. Which option would you choose? Well, first option says the amount of money in the account will increase by 7,290 every year for 10 years. So our equation would look something like, well, we need a variable here. And then if we're getting 7,290 every year, that's just going to be times T. Right? However, my years, it's increasing only by that 7,290. Option 2 says that you will start with $100, and the amount in the account will triple every year for the next 10 years. So I start off with $100, but tripling means I have a power, right? Our base is 3. We're multiplying by 3 every time. And we don't know how many years, so it's going to be 3 to the T power. Right, so that's our 2 options. Bringing us to our first set of questions, it says, well, how much will you have in the account after 10 years if you choose option 1? So option 1 here, I'm using that equation of A equals 7,290 times T. After 10 years here, that means my T is equal to 10. So 7,290 times 10 is going to give me a grand total of $72,900 after 10 years. Alright, so that's my answer. $72,900 after 10 years. Example B. How much will you have in the account after 10 years if you choose option 2? Alright, A equals 100 times 3T. My T though is 10. So 100 times 3 raised to the 10th power. And again, if you want to plug that into your calculator here, I'm going to have 100 times 3 raised to the 10th power. And that gives me 5,904,900. When does option 2 give you more money than option 1? So if I know that this is my grand total for option 1 after 10 years, and I want to look at how many years is option 2 still good, right? Which one is giving me the most money and for how long? So what I have to do is I'm going to take my answer for option 1, 72,900, and I'm going to set that equal to my equation for option 2. This is going to tell me exactly at what point was option 2 now better than option 1. I'm going to simplify it, so I need to solve for that variable, which is my exponent, which means I need like bases, and my variable needs to be by itself. So I have to divide by 100 on both sides. It gives me 729 equaling to 3t. I need to find like bases here, so I'm going to pull up my powers cheat sheet and look at bases for 3. The highest base here is I have 3 to the 4th power, so maybe we need to check out what 3 to the 5th is. 3 raised to the 5th power is only 243. Let's see 3 to the 5th power. Oh, I already did that one. 3 raised to the 6th power. 729. Perfect. That's what I needed. So I can rewrite this left side of 729 to be 3 to the 6th power. 729. So this is going to be 3 to the 6th power. Set equal to 3t. When I have like bases, I set my exponents equal to each other. And t equals 6. Alright, so I'd be waiting 6 years is when option 2 gives you more money than the total of option 1. So stick with option 1 if you're going to get that money before 6 years. Anything after that, option 2 is the best. The one thing I also want to discuss before I let you guys go and work on that activity is when you have like option 2, for example, it just said triple every year. Triple means 3. That's why there was a 3 there. If it would have said double, then you would have that power of 2 as your base. Or if it says quadruple, it would be to the 4th power. So whatever it's telling you you're increasing by each year is going to be whatever base you have to that exponent. Right? You can go ahead and work on your last activity for this unit, which is 1D.3. After that, you guys will be working on the test review and then taking your first key concept test.